Greetings, dear viewers. You are on the Crass Moto channel. 2 years ago, I released an episode about the history of snowmobiles on my channel. In that episode, I only briefly mentioned Aerosleds. While working on that material, I quickly realized that this topic deserves a separate episode. In this video, I invite you to talk a bit about Aerosleds. And now you'll find out what this machine is, when and by whom it was first built, as well as its advantages and disadvantages, how these vehicles conquered Greenland, Novaya Zemlya, and Antarctica, and also how Soviet Aerosled battalions struck fear into the Nazis during the Great Patriotic War. Make yourself comfortable and enjoy watching. By good tradition, let's start from the very beginning. The birth of Aerosleds was preceded by the emergence and development of a number of designs and technologies: internal combustion engines, propellers, skis, and sleds. Without all these things, it would have been impossible for the machines featured in this episode to appear. Sleds and skis are among the oldest inventions of mankind, and perhaps they are even older than the wheel. In ancient times, people found that attaching two specially shaped boards to their feet greatly increased their speed over loose snow, especially when it was deeper than half a meter. Skis already existed 9,000 years ago, as confirmed by cave paintings found in Canada, Russia, and Scandinavian countries. Sleds appeared around the same time as skis and apparently evolved from drags. These items made life easier for all the peoples who lived in areas with long, snowy winters. However, sleds were not used only for moving over snow. In particular, nothing prevents sleds from being quite effective when moving over sand, mud, or a cushion of moss or lichens. For example, sleds were used in ancient Egypt, and even when the transportation revolution brought the wheel, sleds in Egypt remained an important part of burial rituals for a long time. A similar ritual also existed in Rus. Here's another interesting fact. In pre-Petrine Rusum, sleds were widely used for transportation even in summer because roads were poor and sleds were inexpensive. In the swamps of Arkhangelsk, Vologda, Olonets, and Kostroma provinces, sleds were used in the summer until the beginning of the 20th century. And all this time, sleds were either pulled by hand or harnessed to domestic animals, horses, dogs, and so on. They are still often harnessed even now. But the Industrial Revolution, which surged in the 19th century, brought humanity the internal combustion engine, a compact and powerful enough unit to drive various vehicles. The introduction of internal combustion engines to sled design and their use for movement was inevitable. Another important invention that led to the creation of Aerosleds is the air screw, also known as the propeller. It is a bladed engine that, when rotating, creates thrust by pushing air backward at an increased speed. It is claimed that the idea of the air screw dates back to the invention of Archimedes. There is a famous drawing by Leonardo da Vinci depicting a prototype of a helicopter with a lifting screw. The screw still looks like Archimedes' design. In July 1754, Mikhail Lomonosov conducted a demonstration of an aerodynamic model of a propeller. The blades on it were already flattened, bringing them closer to their modern appearance. It is believed that Lomonosov used the image of a Chinese children's toy, the bamboo helicopter. By the late 19th century, the propeller and the prospect of the first heavier-than-air flight thrilled engineers and enthusiasts. Many of them work in workshops and create prototypes that, in their opinion, should be able to fly. As you know, the first flight was made on December 17, 1903 by the Americans, brothers Wilbur and Orville Wright. But before that flight, propellers had already been tested on stands for several decades to measure thrust parameters in order to select the most suitable characteristics of the propeller. One of the scientists who worked in this field was Sergei Sergeyevich Nezhdanovsky. Sergei Sergeyevich was born in Moscow in 1850. In 1868, he graduated from the First Moscow Gymnasium, and in 1873, from the Faculty of Physics and Mathematics of Moscow University. Nezhdanovsky devoted his entire life to research and inventions in the field of practical mechanics and aeronautics. In the 1880s, he studied the problems of creating jet aircraft, and in the mid-1890s, he proposed a number of original helicopter designs. For many years, right up until 1920, Sergei Nezhdanovsky worked closely with Nikolai Yegorovich Zhukovsky. In winter 1904, Sergei Sergeyevich became the first to put an engine and propeller on a sled, studying the propeller's driving force. However, Nezhdanovsky quickly realized that his invention was also a good means of moving across the snow. The design was patented. That's how the Aerosled was born. Some sources give Nezhdanovsky's invention the honor of being the first, calling his sled the world's first snowmobile. Others prefer to consider Alvin Lombard's half-track locomotive, which was used for transporting timber, as the first. However, this is a subject of debate about who built the first snowmobile. The very first Aerosleds were actually designed by Sergei Sergeyevich Nezhdanovsky. During the test, Nezhdanovsky noticed that the speed of his experimental machine varied greatly, depending on the condition of the snow, air temperature, and other external factors. After discussing his observations with Nikolai Zhukovsky, he studied how runners slide over snow. As a result, he was able to derive a number of formulas to determine how the resistance to movement over snow depends on the load and the position of the center of gravity. These conclusions made it possible to determine the optimal sizes and parameters of the supporting skis, and the data obtained soon found wide application in the design of aerosleds. After the appearance of the world's first aerosleds in 1904, Nezhdanovsky gained hundreds of followers. Many engineers and enthusiasts, including Sikorsky and Lebedev, presented their own design options. The idea of using this device as a means of transportation appealed to Yuli Alexandrovich Meller, the owner of the large Moscow factory, DUX, which produced bicycles, motorcycles, and cars, and a little later, airplanes. Yuli Meller had everything needed to make aerosleds: factory, equipment, staff, and, most importantly, money. He started by building a technology demonstrator in 1907. It was a rather primitive design, a metal sled with no steering or braking capability, powered by a single-cylinder de Dion-Bouton engine with 3.5 horsepower. Meller was testing the practical possibility of moving this device, and you could steer the sled just like in childhood, by braking with your feet. Following the tests, a steerable ski was added to the Aerosled. The second sled that was built was longer and apparently was intended to carry 2 people. The snowmobile reached speeds up to 16 kilometers per hour, and although overall the idea of the Aerosled proved itself in this form, it had no chance of commercial success. Also, the airplane layout overloaded the rear skis while underloading the front and steering skis. Because of this, turning and braking the vehicle was difficult. These sleds were displayed at the Moscow Automobile Exhibition on May 3, 1908. Soon, Meller built the first Aerosleds that could be produced in series. The layout became similar to that of a car. The ENV company engine with 40 horsepower was placed in the front, and the torque was transmitted to the propeller by means of a shaft and chain. Sources give different information about the year of construction. Some claim it happened in 1909, but it is known that the first tests of this design took place in February 1911. The Imperial All-Russian Automobile Club organized the motor sled test. Other designs, like Adolf Kigres's car, also took part. The Aerosled, driven by Meller himself, covered 24 versts in 46 minutes and won first prize. The average speed was 33.4 kilometers per hour. On February 7, Meller demonstrated his sled to Emperor Nikolai II, and on February 22, he rode them through Petersburg's streets. There are mentions in many sources that the DUGS Aerosleds were produced in series and were successful among buyers. But, unfortunately, there are no references or photographs of satisfied users of this equipment conquering snowy expanses. So there is a chance that the motor sleds were not really sold much. In 1911, following the DUGS automobile design, the entrepreneur Zheltukov built his own Aerosled. Zheltukov's Aerosled design was very simple: a rectangular frame with the engine in the front and a pusher propeller in the back. The sled had a 15-horsepower Aerosanis aircraft engine. The main feature was steering by changing the thrust vector. The propeller would turn with the steering controls. In this way, Zheltukov tried to increase the maneuverability of the sled. There was also a design of Aerosleds by engineer Burkovsky, which were built in Voronezh in 1911. In that same year, 1911, Meller built another Aerosled with an 80-horsepower Argus engine. During tests in Moscow, this design reached a speed of 90 kilometers per hour. In February 1912, Yuli intended to travel on his sled from Moscow to St. Petersburg, but the journey ended after 45 kilometers. Because of the lack of snow, the sled didn't want to move through the mud. At the start of 1913, Meller traveled to Petersburg on the DUGS Aerosled to join a snowmobile competition organized by the military department. But the gods clearly did not favor the Moscow entrepreneur. The radiator broke on day 1, and on day 2, a spring snapped, hitting a bump at about 75 kilometers per hour. The factory director himself returned to Moscow, and after repairs, the mechanic still managed to reach St. Petersburg. At the exhibition and demonstration runs, there were also Aerosleds designed by Igor Igorovich Sikorsky, produced by the Russo-Balt factory. Estonian entrepreneur Una Pokart Data helped develop Aerosleds. She owned the Una Pokart machine and fabric in Viljandi, producing equipment primarily for local agriculture. But the soul of the Estonian engineer dreamed of flight, and in 1911 he built an original machine for moving over snow and ice. Pokart's Aerosleds were the most original and best made among all examples of this type of machine built at that time. The monoskis, about 7.5 meters long, were equipped with a 3-cylinder Aerosanis engine. The propeller, despite the engine's position, was a tractor type. Of course, the issue of safety with the propeller positioned like that was not a simple one. Only the iron composure of people in the early 20th century allowed them to take the second seat while the engine was running. The Aerosled was controlled using a tailski rudder. On November 16, 1911, the first run was made on Lake Viljandi. The sled hit 30 kilometers per hour. After a quick engine fix, a raid on the lake was done the next day. A local correspondent for the Felin and Zyga newspaper wrote that 4 people at once traveled on the sled at a speed of 70 kilometers per hour over ice in a snow-covered road. It's unclear where they all fit. Never mind. After the impressive demonstration, Pokart sold a sled to the Ruya Estates landowner. As reported by the press at the time, although the Aerosled demonstrations were fairly successful in early 1913, interest had already begun to decline. Meller at his DUGS factory in Sikorsky, at the aviation section of Rusko-Baltijski Vagani Zavod, focused on airplanes. The appearance of the first mass-produced Aerosleds can be attributed to 1912, when the Russo-Baltic plant began building a batch of transport Aerosleds ordered by the military department. By the beginning of the second decade of the 20th century, snowmobile machines had also attracted attention abroad, in France, Austria, Germany, and Scandinavia. And let's talk in a bit more detail about what was happening abroad. Very similar things were happening there. Technical progress pushes people to build all sorts of things. Some design cars and motorcycles, others are fascinated by aviation and so on. The idea of using a propeller as an engine for a land vehicle had already existed in Europe by the end of the 19th century. The earliest design I was able to find is this Aerocar, built in 1903 in France, according to the project of Captain Louis Ferdinand Ferber. Ferdinand Ferber had a huge influence on the development of French aviation, and he built more than one such car to test the thrust characteristics of propellers. We won't go deeper into the niche of aeromobiles, of which quite a few were built in the following decades, we'll leave that for a separate episode. Amid all these experiments with propellers, a number of engineers came up with a perfectly logical idea to combine a sled, an engine, and an air propeller. There are already several successful examples from the Russian Empire. However, there's one nuance. In Europe, no one considered aerosleds to be a demanded means of transportation. Remember your school geography course, where in old Europe does snow lie steadily for several months? There aren't many such places. They include the Scandinavian countries, Finland, Sweden, and Norway, and some mountain ranges, mainly the Alps and Carpathians. An aerosled is quite a specific means of transportation that requires a number of conditions to operate. First of all, open space is needed for effective maneuvering. Getting through a dense forest on such sleds would be almost impossible, and traveling on a winding road is hardly enjoyable either. Secondly, aerosleds prefer flat terrain. Yes, they are capable of going uphill, but only on gentle slopes. So using this kind of vehicle in the mountains is limited. And now, having clarified the specifics a bit, it becomes clear why European engineers considered aerosleds primarily as vehicles for various Arctic and Antarctic expeditions. In order to slightly expand the scope of this technology and attract the attention of car enthusiasts, engineers offered wheeled versions, aeromobiles, as well as combined ones where the wheel was paired with a ski. The first ones were positioned as an alternative to the classic car design, but their suitability for use in heavy city traffic is highly questionable. The issue was safety. Soon after, these cars got casings to protect people from injuries. But this casing didn't change the fact that a car with a spinning propeller would blow everything away. Dust, leaves, and small stones would turn into something like bullets. The craziest designs of this kind were this aero motorcycle, or for example, a series of aero rail cars that were created in Russia and Germany. In the old world, a number of aerosled designs were built, and let's take a look at some of them. The Douglas Mawson Frozen flight was a fascinating chapter in technology development. The story of this aerosled began in 1910, when Douglas Mawson, an Australian and one of the participants in Shackleton's first expedition to Antarctica in 1907-1909, was planning the Australian Antarctic expedition, which was to begin in 1911. Mawson needed the airplane for preliminary reconnaissance and search and rescue operations. The goal of the expedition was to map the coastline of Antarctica in the Australian sector. This was supposed to be the first airplane in Antarctica, and it was part of the expedition's publicity. The first flight in Antarctica, Mawson went to Britain, where he acquired a Vickers airplane. During a demonstration flight in Adelaide on October 5, 1911, the airplane crashed into the ground. The pilot and passenger miraculously survived, but the Vickers was beyond repair. It was a failure. Douglas Mawson reasoned as follows: "Since it can't fly anymore, let's at least drive it on the ice." They removed all the covering and wings from the plane, and in this stripped-down state, it ended up in Antarctica. There, after setting up the base camp, engineer-mechanic Frank Bickerton began repairing and converting the aerosled. And the most difficult task turned out to be designing the brakes. Yes, that's the Achilles heel of all aerosleds. On November 15, 1912, the airplane sled was tested between the base camp and the supply depot established on the plateau near Cape Denison. The test showed that the aerosled steadily reached a speed of 32 kilometers per hour and quite successfully pulled 4 trailers. But during one of the expeditions, the engine began to malfunction, and the polar explorers abandoned the aerosled. Later, the aerosled was towed back to base camp. After Douglas Mawson's expedition, the explorers brought the engine and propeller to Australia, leaving the frame in the Antarctic ice. This interesting aerosled design is associated with the name of the Romanian aircraft designer Henri Coanda. On October 30th, 1910, at the Second Paris International Air Show, an airplane without a propeller was shown. At least that's how it looked. Under the nose cone fairing, there was a turbine that was driven by an internal combustion engine. That's how the thrust was generated. The Conda airplane was built at the Caproni factory in Italy. Its first and only flight took place in France. By the way, that flight ended in a crash. In that same year, 1910, on December 2nd, photographs of the Aerosled with the Conda propulsion system were shown. The sled was built at the Despujol's factory, which produced light boats and motorboats made of plywood. The Conda Aerosled was equipped with a 30-horsepower engine from the Gregoire company. Starting from December 3rd, these sleds were exhibited for 2 weeks at the 12th Automobile Show in Paris, at the Gregoire stand along with cars and engines. The advertisement stated that the expected speed of the machine on snow was 100 kilometers per hour. In 1912, the Aerosled was built by the French Count Bertrand Marie de Lesseps. After his sports career, Bertrand and his brothers Jacques and Paul became interested in aviation and became leading promoters. But by 1912, there were already many innovators and promoters in the sky. De Lesseps looked at his passion from a different perspective, and in 1912 at the Automobile Exhibition in Brussels, he presented a small single-seat four-wheeled car with a propeller engine. On Lesseps's Aeromobile, the 30-horsepower engine's shaft ran under the car's floor and, via a chain, powered the Philippi system shaft. Bertrand quickly realized that the car was not suitable for traveling on public roads. And around the same time, he learned that in the winter of 1913, a snowmobile competition would be held in the capital of Russia. De Lesseps turned his creation into an Aerosled after first testing a combined version. Luckily, he just had to put the wheels back on without removing the skis. In this form, the Aerosled could be transported to where it would be used, like a sled, for example, to St. Petersburg. In Lyon, on wheels on the racetrack, it reached a speed of 92 kilometers per hour. Then the vehicle was placed on a 270-ton barge, and the propeller motor group was tested as a propulsion system for the vessel. The barge moved slowly but confidently along the river. In St. Petersburg, de Lesseps's sleigh competed with the sleighs of Sikorsky and Meller, as well as Kagres's car with a tracked module. The further history of de Lesseps's sleigh is unknown, although from a technical point of view, it was one of the most advanced Aerosled models of its time. With the outbreak of the war, Bertrand de Lesseps himself went to the front and died in 1918, 3 days before the armistice began. In 1913, René Legrand presented lightweight Aerosleds on 3 skis at an exhibition. A V-twin engine powered a front-mounted 2-blade aircraft propeller. The Aerosled was steered by turning the single rear ski. The propeller was completely exposed, and its position at the front caused maximum discomfort for the Aerosled pilot. In January 1914, Legrand used his sled for communication tasks between the garrisons of the Alpine fortresses. It was there that Ernest Shackleton came to see the machine he intended to use in his second expedition. In the mountains, all 3 supporting skis were made double, but still the Aerosled itself was too light and weak for any use other than postal service. Nevertheless, Legrand's work was noticed, and in the summer of 1914, together with the aviation company Breguet, he built larger ones. The Breguet-Legrand Aerosleds were built according to Sikorsky's design. This technology was the French's final attempt to create a separate transport method for snowy regions in France. World War I began, leaving the French no time for Alpine experiments. Since Switzerland was neutral and Italy unexpectedly became an ally, no war was expected in the mountains and snow. Accordingly, combat vehicles were not needed there either. The history of Aerosled development in Imperial Germany is based on a series of photographs and the imposing figure of Hindenburg. Here's a photograph dated 1911, which was published in the magazine Spiegel. It shows simple wooden sleds powered by an air propeller, which most likely, like the Russian Aerosleds of Nezhdanovsky or Sikorsky, were intended for testing propellers. The first time fully developed German Aerosleds were shown was at the Automobile Exhibition in Berlin at the end of 1911, which was reported to the whole world by the popular American magazine Popular Mechanics in January 1912, featuring the Aerosleds on the cover page. Hindenburg personally pushed for sled construction development in Germany as part of war preparations in the winter of 1914. 1915, He inspected armored sleds somewhere in East Prussia, possibly at the Boyen Fortress, where this rather famous photograph was taken. These German sleds were the first to be armed with a centrally mounted machine gun. Perhaps the Aerosleds that were made were constructed from thin armor plates or unarmored steel. The engine was located in the rear part. The sled was controlled using a pair of small skis located at the front. The track width of the main support skis was wider, which provided greater stability. The German designers took a thorough approach to the sled's design, adding a wheel drive for movement on non-snow surfaces. There is no mention of series production for this equipment. These sleds were probably made in 1 or 2 units for testing. Since we've discussed World War I, it's worth noting that the Russian Empire used Aerosleds most successfully. By winter 1914-1915, these sleds were used for reconnaissance, communications, and other tasks assigned by command. The participation of snowmobiles in combat operations was so successful that in mid-1915, the All-Russian Zemstvo Union, which was responsible for supplying the army, was tasked with launching the production of transport aerosleds for the needs of the front. By winter, in the automotive department of the VZES, headed by Professor Nikolai Romanovich Brilling, and with the participation of the department's engineers Kuzin and Arkhangelski, they developed and then, in the VZS workshops, built a batch of 24 Aerosleds. Some of the sleds were armed with machine guns, while the rest were intended for transporting the wounded. The use of this equipment at the front showed that they could successfully meet military needs, provide operational communications, deliver ammunition, and handle other transport tasks. Following the Great October Socialist Revolution and during the Civil War, the Red Army used several Aerosleds previously built by the VZS Automotive Department. Interventionists also used Aerosleds. In the Far East, the Japanese used them, and in the North, the British did. The Kolchak forces in Siberia also used Aerosleds. In the winter of 1918-1919, as difficulties with railway transport increased, the Red Army's need for all-terrain vehicles became especially acute. Engineer Kuzin proposed one of the most successful designs. To give an assessment of this vehicle, a commission was organized, consisting of Zhukovsky, Vichinkin, Stechkin, and Tupolev. As a result of the commission's meeting, it turned out that this was exactly the kind of equipment that the young Soviet country was lacking. That's how, in fact, the first serial Aerosleds of the Soviet Union came into being, and they were called BK. In old sources, you can find a version of the name that is read as a transcription of these 2 letters, BK. This meant sleds designed by Brilling Kuzin. A new committee called Kompas was created for the development and production, and the DUGS factory began manufacturing these Aerosleds. The BKs were equipped with a Hall-Scott engine with 125 horsepower and water cooling. A total of 9 BK Aerosleds were built by May 1920. The 10th unit was built the following winter. The tests of the sleds for the Red Army showed that they had quite decent mobility over snow and frozen mud. The average speed during the run near Moscow, over 50 versts, 53.34 tililiter, was 28 kilometers per hour. After the end of the Civil War, the production of Aerosleds continued. Brilliant. Zhukovsky, Tupolev, Arkhangelski, and many other talented engineers and designers worked on these designs. In this photograph, you can see the R-base sled designed by Arkhangelski and Stechkin from the year 1920. Namy also mastered sled production. Between 1920 and 1921, engineers Karelsky, Klimov, and Christie built the Aerosani 3K. The name was due to the fact that the last names of all 3 designers started with the letter K. The Aerosani 3K joined initial test runs, Moscow-Sergev, Posad-Moscow, 140 km, and Moscow-Tver-Moscow, 340 km. These runs revealed the pros and cons of various Aerosani designs. At the same time, the 3K proved to be very unpretentious and completed the entire route without any problems. Unlike SAGA, which built duralumin vehicles, at NAMI due to the shortage, the use of non-ferrous metals was minimized. Therefore, when developing snowmobile vehicles at NAMI, with rare exceptions, preference was given to all wooden or mixed constructions. Several types of NRB and KAS Aerosleds, various NAMI 36 models, and others were built and tested in the laboratory and later in the department. They were tested in Aerosled runs in 24, 26, and 27, along with SAGA Aerosleds and others. Using experimental data and test run reviews, the designs were refined and new drawings created. When the first NAMI sleds were manufactured, mainly surplus, previously used engines were used. At the same time, there was a large number of already outdated aircraft engines available in the warehouses. The most suitable were considered to be the 9-cylinder radial Salmson, engines with 150 and 160 horsepower, the inline 6-cylinder Hallscott with 125 horsepower, and the 8-cylinder Hispano with 150 horsepower. Tupolev, under the influence of Zhukovsky, firmly decided to devote himself to aviation and had no doubt about the great future of airplanes built entirely out of metal. However, his theoretical views required further development and verification, and it was precisely the process of creating Aerosleds that allowed Tupolev to test the principles of using metals in aircraft construction in practice. The first ANT, one sleds built in 1920, had a wood metal body, were equipped with a 38 horsepower Anzani engine produced by the Bristol Company, and could carry 2 people. Another model, the ANT-2 Aerosled, was larger and designed for 5 people. With a Clerget engine producing 115 horsepower, these Aerosleds weighed 680 kilograms and could carry 480 kilograms of cargo. In February 1923, the ANT-3 sleds were ready, marking a new stage in the development of domestic Aerosled construction. These were the first sleds in the Soviet Union with an all-metal aluminum body. The body had a streamlined shape and could accommodate 3 people. The driver sat at the front in the open body, shielded from the wind by a small transparent visor above the instrument panel. 2 passengers were seated in the enclosed cabin. The Aerosled used a Gnome-Wren rotary aircraft engine with a power of 80 horsepower. Starting with the ANT-3 Aerosled, all subsequent ANT designs had an all-metal body and a 3-ski chassis. In January 1924, it was possible to simultaneously complete the construction of 2 models at once, the 5-seat ANT-4 and the 3-seat ANT-5. Both models were powered by engines with 100 horsepower. The ANT-4 was equipped with an M11 engine designed by McEulin, while the ANT-5 had a Lucifer engine from the Bristol Company. After state trials, the ANT-4 and ANT-5 were put into mass production at the Kolchuginsky plant in 1926 and in Leningrad in 1933. The ANT-4 model was exhibited at the International Exhibition in Berlin in 1928. In winter 1929-1930, the first experimental postal route using Aerosleds operated between Cheboksary and Kanash. In January and February 1930, the ANT-4 with a Lucifer engine traveled 5,260 kilometers, carried 244 passengers, and delivered 1,132 kilograms of cargo. The distance from Cheboksary to Kanash, which is about 70 kilometers, was covered by Aerosleds in 2 days, instead of the 10 to 12 hours required by horse-drawn transport. ANT-5 Aerosleds took part in the expedition of geologist Mikhail Mikhailovich Yermolayev to Novaya Zemlya in 1932-1933. Soviet scientists planned to use Aerosleds to establish communication between the bases. No one minded that the ANT-5 had an open cockpit. In 1937, our people even flew to the pole in an R6 with an open cockpit, and it was fine. The narrow duralumin body only fit the driver, 2 passengers, and little cargo, but this wasn't seen as an issue. However, the Aerosleds crossed the island twice on the Ruskaya Gavan Bay of Prosperity Line and traveled the ice sheet axis route. There were breakdowns, but each time they managed to fix them. Once, Yermolayev even had to cross the ice sheet of Novaya Zemlya because of a sled malfunction. As a result of the expedition, the experience of using the sleds was considered successful, and those very ANT-5S were handed over to Obrachev's geological expedition, which was heading to Chukotka. A feature film about Yermolayev's expedition, The Seven Brave Ones, was released in theaters in 1936. Because of this film, confusion arose later. Many historians believe that Yermolayev had more modern AANT-4S with an enclosed passenger cabin, which are shown in this film. Before 1939, more than 20 models of Aerosleds were created in the Union of Soviet Socialist Republics. Several designs were developed in the Department of Hydrofoil and Aerosled Construction in 1932. In 1934, the organization became a factory mass-producing NKL vehicles designed by Chief Engineer Andreev. The best known are the NKL-6, produced from 1934, NKL-16, 1937, and NKL-26, mass-produced from early 1942. At the end of 1935, the Krasny Metalis plant in Gorky, under the supervision of Chief Engineer Veselovsky, began production of the KM-4 Aerosleds. A prototype Aerosled arrived in Moscow under its own power in 1936, where Workers' and Peasants' Red Army People's Commissariat for Internal Affairs and People's Commissariat of Communications officials conducted state trials. These showed the KM-4 was suitable as an ambulance, passenger, and airfield vehicle, but not recommended for expeditions. As a result, the Aerosleds were accepted for mass production. Many Aerosleds of the 1930s in the Union of Soviet Socialist Republics were designed in three versions: transport, ambulance, with provisions for carrying stretchers in a closed compartment for a medical worker, and combat. A machine gun was mounted on a rotating turret on the sled. The Red Army widely used propeller-driven snowmobiles in combat operations during the Soviet-Finnish War of 1939-1940. Various models of Tupolev Aerosleds were used, mainly the ANT-4 as well as the NKL-6 sleds. The latter, equipped with a machine gun mounted on a rotating turret, took part in combat operations, patrolled open sections of the front, and guarded facilities. Thanks to their high speed and good maneuverability, these combat vehicles were very effective for detecting enemy firing positions and adjusting artillery fire. They were also used for communications, transporting ammunition and delivering food. The NKL-38 Command snowmobile was adopted, followed by the NKL-12 Cargo Aerosleds for field operations support. These air platforms were used to transport fuel in barrels, deliver aircraft engines and other equipment to the planes. The Great Patriotic War forced the intensification of work on creating new types of Aerosleds. It's already late June 1941. In accordance with the assignment from the Council of Labor and Defense to prepare the Red Army for winter, industry was tasked with developing reliable combat and transport Aerosleds, ensuring their mass production by the beginning of winter. At the same time, a special department of the Red Army was established within the armored forces, which was responsible for all organizational work and the support of special combat and transport Aerosled units. The effort grew so much that the first Aerosled battalions were formed that year, handling key assignments from command. Production started on new combat sleds, the NKL-26 and RF-8, designed by Andreev and Veselovsky. Transport sleds NKL-1641 and later NKL-1642 were also made. The NKL-26 featured an interesting design. To protect against bullets and shrapnel in the front projection, a 10mm thick armor plate was used. Both pairs of skis were steerable, which provided excellent maneuverability for the vehicle. These vehicles, organized into combat and transport battalions, reached the active army in late December 1941 and January 1942. An interesting design was the Heavy Assault Aerosled ASD 400, designed by engineer Alexei Beskurenkov. Alexei became fascinated with these machines in his youth when he saw Aerosleds in Moscow in the early 1920s. In 1925, together with his friends, he built his first Aerosleds, and in 29 he already got a job at OSGA. Beskurenkov was involved in the construction of the OSGA-2 sleds. In polar expeditions, this equipment performed excellently, and during one of the runs, it set a speed record for Aerosleds, 112 kilometers per hour. With the outbreak of the war, the team of designers led by Beskurenkov received a government assignment to design powerful 25-seat Aerosleds in the shortest possible time. These Aerosleds had to be able to transport not only people, but also all kinds of cargo in harsh winter conditions. The assignment was completed. The ASD-400 Aerosleds, equipped with an M22 aircraft engine producing 400 horsepower, were built and demonstrated good performance in operation. Another notable design that wasn't further developed was the snow tank, TSKB-50, built in Leningrad. TSKB was tasked with building heavy Aerosleds weighing about 3.5 tons. The project was named 02SS. At the concept development stage, it was not possible to stay within the weight limits. The experimental sleds, built in 41, weighed 4.7 tons. They were also extremely expensive, costing more than a T-50 tank. During testing, they performed very poorly. They were hard to control, and the 860 horsepower engine was not enough to conquer even small inclines. Consequently, the project was abandoned. In combat, lightweight sled designs were most effective. In addition, a machine gun was mounted on the sled as a support weapon, and they carried a small number of infantrymen. Quite often, using ropes, they towed a couple of sledges with a machine gun crew behind them. Up to 20 more infantrymen on skis. Aerosleds saw use on many fronts: at Stalingrad, defending Moscow, on Lake Ladoga's Road of Life, and more. In early 1942, the Hitlerite army retreated from Moscow's outskirts because of strong Soviet resistance, especially from the 16th Army led by Konstantin Konstantinovich Rokossovsky. Aerosleds played a key role in Moscow's defense, with the 16th Army creating over 20 combat transport battalions. Rokossovsky often mentioned this equipment in his book, A Soldier's Duty. Aerosleds struck terror into the Germans in the winter of 41 to 42. In conditions where the snow was about a meter deep, when even tanks became sluggish, the attacks of the Aerosled battalions were lightning fast and accompanied by the roar of air propellers. At first, due to the lack of intelligence data, the German command thought this was some kind of new secret Soviet armored vehicle. Later, during the fighting, the Germans captured a number of Soviet Aerosleds and used them for their own purposes. The Germans also used Finnish motor sleds in combat, but on a much smaller scale, and they tried to build their own as well. The 1942 Tatra Vi-855 is an example of this. However, it never went beyond the prototype stage. We will talk in more detail about Finnish and German Aerosled designs in the next chapter, and we will dedicate a separate chapter to Soviet Aerosleds after 1945. From the part of the story we've already covered, it might seem that foreign countries didn't pay much attention to designs with skis, an engine, and a propeller, but that's not entirely true. In the third chapter, we looked at Aerosleds originating from European countries and stopped at the time of the First World War. However, the First World War was not a turning point after which the development and construction of Aerosleds stopped. Various events of that period actually put everything in its place, and after the war, the development of Aerosleds was mostly undertaken by those countries where snow cover remains for a long period of time, either throughout their territory or in part of it. Among these, it is worth mentioning Finland, Canada, the United States of America, and some other countries. Aerosleds had been built more or less actively in Finland since the late 1910s. At first, they were made by hand, and later at Finland's largest aircraft factory, Valtion lento conectadas. The designer of these sleds was Arva Tervasma, an employee of the Finnish Air Force. His surname was Tenlinius until 1935. He designed every Finnish aerosled from World War I, and yes, in many photos I had to blur out the solar symbol of the Third Reich so I wouldn't get blocked on YouTube. The first Finnish aerosleds can be dated to the first year of this country's independence. The first prototype of small aerosleds was built at the Santa Hamina airfield in 1919. In the same year, Asser Järvinen designed his own sled. It was a large and heavy structure with 3 skis that could hold 15 people. The sled had a Ben engine producing 150 horsepower. After the end of the Civil War in Finland in 1920, a Finnish ranger named Arva Tenlinius joined the Air Force and was full of hope to become a first-class pilot. However, one incident in the aircraft workshop would shatter his dream. A metal shaving got into Tenlinius's eye. This badly affected his eyesight, and he had to forget about further flights. In 1921, he was transferred to Santa Hamina, where he became acquainted with Järvinen's Aerosled. Arva was so impressed that he started developing his own designs. The first sleds that Arva built had 3 skis, just like Järvinen's design, but the next models he built had 4 skis. The first known case of polar explorers using aerosleds was Alfred Wegener's expedition in 1930-31. Back in 1911, Douglas Mawson used an aerotractor in his expedition, but that was a forced measure, using a damaged Vickers airplane. Let's get back to Wegener. By then, the German meteorologist and geophysicist was an experienced traveler and already 50 years old. By the way, this is the same Wegener who came up with the theory of continental drift. Alfred set out to study the Greenland ice sheet and took with him 2 Finnish aerosleds designed by Arvo Tervasma for this expedition. They tested the sleds in Finland before the expedition and were satisfied with them. However, once in Greenland, it turned out that this remarkable machine couldn't move at all on loose snow. Either the engine wasn't powerful enough, or the problem was with the massive wooden skis. Most likely, it was both. Besides, they had to climb up onto the ice sheet. To do this, the aerosled was dragged up the steep icy slopes. In the end, the sled didn't perform very well. The supplies and equipment had to be rushed to the Ismita station, 400 kilometers away, by dog sled. At the end of the 1931 expedition, the aerosleds were left at the ice sheet's edge, and the engines were taken back to Germany. Arva Tervasma was actively developing sleds for the military needs of Finland and Germany. By the start of the Winter War and World War I, Aerosled's characteristics had greatly improved. His sleds were actively used during the war for winter transportation between Finland and Norway, and for patrolling along the borders of Finland. After leaving the Air Force in 1946, Arva became technical director at the Kuopio Munitions Factory until 1949, then served as managing director until retiring in 1956. In the winter of 1941-1942, the Germans encountered Soviet aerosleds in battle. For the Wehrmacht, it would have been quite logical to also have some equipment capable of traversing deep snow. However, by the summer of 1941, the German industry was not producing aerosleds. Finnish designs were considered as an alternative, but only a few existed. The Hitlerites used captured Soviet motor sleds whenever possible. In the winter of 1941-42, the Wehrmacht asked industry to develop a vehicle capable of operating in snow-covered Russia. The order was not a high priority, which meant it was not very profitable. Few were willing to take it on. By the next winter, only one prototype reached testing, the Czech Tatra Fiat 55. The vehicle was solidly built in the usual European style. The meticulous Czechs took into account all the military's requests and anticipated everything, including a special drive system. This lowering roller at the back, that's it. This roller was designed for low noise movement, and it could also serve as a brake or, on the contrary, help the structure climb fairly steep slopes. They ended up with a truly remarkable machine, But after considering everything, the designers forgot one important word: money. Their efforts resulted in something very complex and costly. While the Wehrmacht tested the machine, they issued clarifications and requests. The winter of 42 to 43 was over, and by the winter of 43 to 44, the Germans no longer cared about Aerosleds. The war had shifted to regions where there wasn't much snow. Only 2 units of the Tatra V855 were produced. Another and more successful German attempt to build an Aerosled was a design called Max Henschel. The basis was the captured Soviet 3-ski Aerosled NKL-16 model of 37. The main components, the rear ski suspension, the ski design, and the brake, were copied from the Soviet sled. The body shape was also similar. In total, several dozen Max Henschels were produced. These sleds had a 110 horsepower engine and were armed with a 7.62 caliber machine gun carrying 1,500 rounds. This marked the end of the Germans' attempts to build Aerosleds. Sweden also made an attempt to build combat sleds during World War I. The armored design called Slyenden was difficult to control. Apparently, it never went beyond the prototype stage. In the snow-covered territories of the North American continent in the first half of the 20th century, favorable conditions developed for the creation of Aerosleds. Aviation in the United States and Canada was actively developing, and many engineers and enthusiasts were working on creating vehicles that could efficiently move across snowy terrain. Some of the first known Aerosleds in Canada were built by Joseph Armand Bombardier. Yes, the same Bombardier who in 1959 created the concept of the lightweight snowmobile. But back in 1922, Joseph Armand built a basic Aerosled in his workshop. By the way, at that time, Bombardier was very young. He was only 15 years old. For this homemade creation, Joseph got a good scolding from his father, who was afraid that the propeller would chop off the hands and heads of his son and his friends. However, Bombardier did not give up on his attempts to create snow vehicles, but he did not return to Aerosleds. There were many different models of snowplane. That's one of the names for Aerosleds in the English-speaking world of North America. The main manufacturer of Aerosleds in Canada was Carl Lorch. The ingenuity of the young mechanic from the province of Saskatchewan made him famous in all the provinces of Canada, in the northern United States, and even in the distant Soviet Union. Tinkering in his workshop, Carl was guided by ideas similar to those of Bombardier. At that time, there were few roads in Canada that snow removal equipment could reach during the winter. His first attempt at creating snowmobile transport was made around 1928. He modified a Ford Model T by narrowing the track to the width of a sled and shortening the wheelbase. He installed skis in the front and put chains and plates on the rear wheels to improve traction. The vehicle managed the task, but Lorch was not satisfied. One day, Carl, while near the airfield, saw a light plane with skis land and then continue moving along the extra strips toward the hangar. That's how he got the idea for an Aerosled. In 1929, Carl created a 3-ski design with a Ford engine, and during the tests, he continued to make changes and improvements to the design. In the following years, only aircraft engines were used. The track width of the Aerosleds was standardized and matched the trail left by traditional horse-drawn sleds. Riding on a packed ski track in an Aerosled was an indescribable experience. You didn't need to steer with the skis or turn the wheel because the track would guide the Aerosled to its destination. For example, to the grocery store for some whiskey. As Lorch's snowplane became famous, requests poured in from all over. Aerosleds were sold across Saskatchewan and Manitoba to doctors, post offices, rescue teams, gamekeepers, forest rangers, geologists, and others, and also to many private individuals throughout Canada and the northern United States. Production of Lorch's snowmobiles ceased in 1955. By that time, the company had produced more than 600 units. The reason was the development of snow removal equipment and the increase in its quantity. Canadian roads became more accessible in winter, eliminating the need for all-terrain vehicles. The contribution made by Lorch snowplanes to the lives of hundreds of North American residents is impressive. People of various professions were able to do their jobs much more efficiently thanks to this very equipment. The story of Robert Fodge's Aerosleds is quite similar to that of Lorch. Fodge built his first snow sedan in 1929. 3 years later, he began producing Aerosleds for sale. Between 1932 and 1956, about 400 Aerosleds were built in the city of Moosomin in the province of Saskatchewan. Like Lorch and Bombardier's designs, these were used by various services and private individuals. The Canadians' United States neighbors kept up, as several northern states also have long, snowy winters. There were also plenty of engineers here who came up with the idea of building Aerosleds. Some even managed to put the production of such vehicles on a regular basis, even if only in very small batches. Various types of snow vehicles began to appear in the United States in the 1920s, and the earliest Aerosled designs date back to the 1930s. This fact is confirmed by these old footage, where we see a rather primitive three-ski design that was used for mail delivery in the 1930s. A very interesting Aerosled design was presented by William Schomers in 1949. Schomers served as a military pilot in World War I. After returning from the war to his home state of Colorado, he started building a vehicle capable of moving over snow and water. The result of his work in '49 was an Aerosled called Christie. The design featured a tubular frame, an aviation 4-cylinder boxer engine, and 3 skis. At first glance, nothing unusual, but this snowplane had one interesting feature that made it unique. Schomers' design had a ski action feature which allowed shifting the weight by raising and lowering the rear skis. This feature not only helped the Aerosled make quick turns, but also allowed it to cross slopes along their length. The ski action design patent was filed in 1949 and granted in January 1955. For use on water, the skis were replaced with floats. In total, Schomers created 7 Christie sleds, and by the late 50s, he switched to developing various tracked all-terrain vehicles. In the 1950s, the Durango, Colorado company produced Aerosleds. Another guy, Leland McCracken, built about 15 Aerosleds of his own design at his home in Jackson Hole. This equipment was used in particular in some national parks, such as Yellowstone or Grand Teton. However, in December 2000, they were banned for environmental reasons, specifically because of the high noise level of the propeller. And finally, here's a photograph of Icelandic Aerosleds, built in 1952. At the end of this chapter, I want to note the fact that many enthusiasts and small groups in Canada, the United States of America, and Scandinavia not only worked on creating snowmobile equipment, inspired by the work of Lorch, Bombardier, Tervasma, and other well-known designers. They all had the same goal, to make life easier for themselves during the long, snowy winter. The mid-20th century proved a turning point for this equipment class. As you can see, after the 1950s, the number of Aerosled developments noticeably decreased, both in the Western world and in the Union of Soviet Socialist Republics. There were several reasons for this, starting with the fact that in Canada, snow removal from roads became much more efficient and on a larger scale, and ending with competition from other designs intended for traveling over snow. It's important to know that technology develops within a specific environment. Alongside Aerosleds, various designs with tracked propulsion, snowmobiles, motonarts, toboggans, and so on were also being developed. With various snow designs. Each type of this equipment had its own list of advantages and disadvantages. With the arrival of light, powerful, and fuel-efficient snowmobiles in the 1960s, Aerosleds lost out to them. Let's go back to the Soviet Union. We left off at the time of the Great Patriotic War. After the war ended, most of the transport Aerosleds were transferred for use in the national economy. Many NKL-26 and NKL-16 were transferred to the Russian Soviet Federative Socialist Republic Ministry of Communications. They were used to deliver mail on regular routes along the Amur, Lena, Ob, northern Dvina, Pechora, and other rivers. By the mid-50s, the issue of replacing all these Aerosleds arose. After years of use, their components and assemblies were heavily worn. The Soviet country needed new designs. The development was assigned to several design bureaus, one of which was Kamov Design Bureau. At the end of the 50s, the Sever II Aerosled was developed based on the body of the Pobeda car. The vehicle went into production in 1959 and was manufactured at the Progress Aircraft Plant. Arsenyev Primorsky Krai. The design was quite interesting. The body of the Pobeda car was mounted on 4 skis. As for the engine, they initially planned to use the 160 horsepower M11F, but Kamov insisted on the more powerful 260 horsepower AI-14R. Its potential was enough to move the Aerosled, weighing 2.4 tons across untouched snow at a maximum speed of up to 60 kilometers per hour. In 1959, about 100 units of the Sever II sled were built. The average mileage of these vehicles was 12 to 15,000 kilometers per year on postal routes. The equipment was used in Siberia, the Far East, and Kazakhstan. The Pobeda's return on skis after a long pause in Aerosled building was a welcome event. However, the design was quite controversial, since using a passenger car body for an Aerosled is a bad idea from the start. The fact is that a car body is not designed for the kinds of loads that motor sleds experience. According to statistics, the loads on the fuselage of an Aerosled are about 5 times greater than the loads on the body of a typical passenger car moving on a solid road. The project turned out to be unsuccessful, and by the mid-60s, all Sever IIs were taken out of service after several emergency situations, which fortunately did not result in any fatalities. The developers decided that the next project would allow minimal liberties and experimentation. It is necessary to follow the proven aviation path. The K-30 Aerosleds appeared. They were named according to the same principle as the Kamov Design Bureau helicopters. Some say the K-30 is just a RAV minibus on skis, but that's false. The body of the K-30 was made to look like minivans of those years, but it was manufactured using a completely different technology, made not from welded steel panels, but from riveted duralumin sheets, like airplane and helicopter fuselages. Only the steering system and some small parts were borrowed from automobile manufacturing. The K-30 used the same 260 horsepower AI-14R engine as the Sever II, and could reach speeds up to 100 kilometers per hour. The Aerosled could carry 600 kilograms of cargo, or 8 people. The first K-30 prototype was developed and built in December '61. It was decided to produce a small batch for various types of testing. A year later, in December of '62, a batch of 6 units was ready. One vehicle was immediately given for strength testing and sent for trials to Komsomolsk-on-Amur and 2 to Yakutsk. And a couple of years later, by the end of '64, the Progress plant produced 28 K-30 Aerosleds, which already had a design improved based on the test results. From '66 to '79 inclusive, the K-30 was produced in series, with 25 to 35 units per year. That is a total of about 350 to 400 units rolled off the assembly line. It was calculated that on northern local routes of about 60 to 80 kilometers, it was much more practical to use the K-30 than the Mi-4 helicopter. With the same capacity of 8 to 10 people, the cost of the trip was several times lower than the cost of a flight, and the Aerosled could operate in much more difficult weather conditions than the helicopter. Kamov Design Bureau's product was also used in summer. With skis swapped for floats, the K-30 served as a river bus. The new Aerosled designs from the Tupolev Design Bureau were also notable. In 1957, talented engineer Gleb Mokhotkin joined the Bureau. At that time, there were 2 types of non-flying, propeller-driven vehicles in the world, aerosleds and airboats. Completely impractical aerocars had already been abandoned by that time. In the Union of Soviet Socialist Republics, as well as in the rest of the world, there were attempts to put aerosleds on floats. But this concept had a number of drawbacks. One of them was the need to spend time and effort switching between skis and floats, and vice versa. Mokotkin decided to create the Glisser Aerosled, which would combine all the positive aspects of these two designs. In 1961, he showed his project to Tupolev, who supported him. Calculations and model tests showed that the optimal solution to this complex technical problem could be found if the body of the vehicle was designed in the form of a ski boat. As a result of careful development, an amphibious aerosled design was created. In April 1961, the first prototype tests were conducted at the Istra Reservoir near Moscow. And in May 1962, the vehicle was handed over to one of the Ministry of Communications divisions for trial operation. By then, the designers had found another way to improve the Aerosled's performance. A small step was added to the bottom of the boat, which made it possible to significantly increase its speed on water. At the same time, the size of this step had little effect on the Aerosled's behavior on snow and did not require its removal in winter. In the summer of 1964, the drawings were sent to the factory for mass production, and on September 14, 1964, the first production amphibious Aerosleds called AA3 were released. The Aerosleds were powered by an M14B engine with 350 horsepower. The maximum speed on water was 80 kilometers per hour, and on snow, 100. Pay attention to the vertical rudders of the A3. They are slightly embedded in the snow. This has minimal effect on speed and maneuverability, but it allows the sled to brake effectively on snow by spreading the rudders apart. By January 1965, over 100 A3 units were operating in the Union of Soviet Socialist Republics' national economy. They were used for communication, providing medical assistance, transporting passengers and cargo, and conducting rescue operations in off-road conditions. 3 amphibious Aerosleds were used in the search and rescue service of the cosmonaut team. More than 800 A3 Aerosleds were produced at 2 factories in Moscow and Mukachevo, Ukraine. These vehicles were in operation until the late 80s. A small number of A3s were also sold to Hungary, Finland, and Canada. At the request of Leonid Ilyich Brezhnev, who took a liking to the A3 amphibious vehicles smaller and lighter, Aerosleds were designed. Only 400 kilograms compared to 2,100 for the original A3. The 4-seater vehicle was powered by an engine with only 35 horsepower, but it was capable of reaching speeds of 40 to 50 kilometers per hour on snow. 3 such vehicles were built. 2 of them were handed over to the State Hunting Reserve of Zavidovo, and the third was used at the base in Dubna for testing purposes. Alongside serial and mass-produced models, the Union of Soviet Socialist Republics also developed many experimental Aerosled designs and prototypes. For example, this photo shows Aerosleds built by Moscow Aviation Institute students using a Yakovlev Design Bureau experimental helicopter fuselage. Or here are small Aerosleds called ELF with an RMZ 640 engine, which began production at the Progress plant in the late 80s. In no case should we overlook the work of many enthusiasts and craftsmen who built various types of Aerosleds in their own garages for everyday and household needs. Moreover, the garage engineering movement in the Union of Soviet Socialist Republics was highly developed and supported by various educational and scientific technical literature. The Union of Soviet Socialist Republics saw less diversity in Aerosled designs in the second half of the 20th century than in the 1920s, 1940s. However, if you look at it from another perspective, several reliable models were produced in large enough quantities to meet the needs of the national economy. In this chapter, I discuss modern Aerosleds. Throughout the narrative, we have witnessed the emergence of this design, a surge of interest in them, which gave rise to a variety of different machines of all shapes and sizes, and the gradual decline of this type of transport under the pressure of competing all-terrain vehicles. Modern industry can offer consumers equipment for every taste and practically for any task. And in most cases, when vehicles have similar speed and off-road capabilities, people will choose the one that is cheaper to buy, easier to operate, and has a lower cost per kilometer traveled. Aerosleds still exist and are produced in series to this day, and they are used exactly where it is profitable and practical. Yes, in today's reality, this is mainly a departmental vehicle. Most are used by postal services, the Ministry of Emergency Situations, certain agencies, the Ministry of Internal Affairs, and some by the armed forces. Let's begin our look at modern designs with Russia's skis and propeller, the Soviet Union's successor. I think there's no need to explain that during the Perestroika period, work on designing aerosleds was very weak. Perhaps the very first aerosleds in modern Russia were the machines called Yukon. Designer Vadim Vyloshnikov conceived the Aerosled glider in 1992. He shared his thoughts with his friends. That's how an initiative group was formed, and in 3 months they managed to create a working prototype. The stage of searching for funding began. The idea appealed to the company Yukon. The first model, called Yukon, went into production as early as 1993. The Aerosled boat weighed 200 kilograms and could carry an equivalent weight. It was powered by RMZ engines with a capacity of 30 horsepower. Interestingly, the bottom of the Yukon one was flexible due to inflatable elements. However, in 1996, the company Yukon, experiencing financial difficulties, eventually went bankrupt. The initiative group also disbanded, and Vadim Vyloshnikov continued working on his designs alone. He experimented with an engine from an AK car, 45 horsepower, and with a VIKHR 30 boat motor. The development of the A3 amphibian by Mokotkin immediately inspired followers, and soon similar vehicles were designed by other companies. It was later discovered that Florida also produces similar machines that travel through swamps and move on water, snow, and ice. Meanwhile, at the Tupolev Design Bureau in the mid-90s, they began developing a second-generation amphibian called the AES-2, which only recently started being produced in series. The distinguishing feature of the AES-2 compared to the A3 is the presence of suspension between the bottom and the body, which makes riding in this amphibian more comfortable and also significantly reduces the load on the components, extending their service life. The A3's 350 horsepower aircraft engine was swapped for a 150 horsepower ZMZ car engine, making maintenance much easier. To ensure that the reduction in power didn't significantly affect the vehicle's speed characteristics, the propeller was installed inside a ring. This allowed the thrust on the AES vehicle to be increased by 30%. In addition to the Tupolev Design Bureau, there are several other companies in Russia that manufacture aerosleds. A number of aerosled models are produced under the NERPA brand. The 550 and 650 models are structurally amphibious sleds, similar in design to Tupolev's. A similar design, combining the advantages of a boat and a sled, is produced by the Patrol Company from Saratov. This equipment is used by various services as well as by fishermen, hunters, and enthusiasts of this kind of activity. This amphibious tetramaran Arctica is now produced in Finland. The equipment is specially designed to operate in the extreme conditions of the Arctic North. Arctica is used by geologists, oil and gas workers, the Ministry of Emergency Situations, and border guards. The main advantage of Arctica over similar vehicles such as hovercraft, snowmobiles, and airboats is its unique ability to overcome hummocks and move from water onto ice up to 70 centimeters high. The two-section design of the vehicle, the separate crew cabin and engine compartment, along with the independent system of float pontoons, provide additional stability when moving over rough terrain. The body is made of reinforced plastic. The power unit is a Steyr diesel engine with a capacity of 250 horsepower. Various tracked vehicles are used in the United States for all-terrain purposes. And in the warmer states like Florida or Louisiana, various airboats and hydroplanes have become widespread. I don't rule out the existence of aerosleds and amphibious vehicles for military purposes. An interesting modern record was set by a team of 10 people on 3 ski aerosleds crossing the Antarctic ice dome. This happened in 2010. Several wheeled all-terrain vehicles accompanied the Aerosleds. The distance of 1,946 kilometers was conquered in 303 hours. In this video, we are most likely watching tests of these Aerosleds not in Antarctica. You can see trees. The machine features a BMW Boxer engine. Currently, there are some small manufacturers of Aerosleds in Finland, Canada, Norway, and Switzerland. Sergei Nezdanovsky's invention, indispensable for endless snowy plains, is still alive today. Friends, in this extensive segment, we have taken a detailed look at Aerosleds, their technical features, the history of this class of vehicles, interesting models, as well as various facts about the use of these designs. And it's a good thing I didn't go into detail about them in the episode about snowmobiles. I'm not claiming to be 100% accurate, and I don't rule out the possibility that I might have missed something during the narration or made a mistake. If you have something to correct or add, please leave it in the comments. I think the material is rich and interesting, but it's up to you to decide if it's worth watching. If you enjoyed this story, don't hesitate to show your support. Subscribe to the channel if you haven't done so yet. Recommend this video to good friends and acquaintances who are curious about various technical things, and leaving a comment under this video will also help with its promotion. And if you want to support my work financially, the details are in the video description. As always, this was the Crasmodo channel. Thank you so much for watching and for your time. Here are some video suggestions about snowmobiles and screw-propelled vehicles. If you haven't seen them, I recommend checking them out. See you next time.